Perfect. Okay, well, thank you very much, Carmen. It's a pleasure to present today. So I'm going to give a quick presentation on the state of Java on RISC-V. We have been doing a lot of great work at Adaptium on that. And I would love to share more widely what we're up to and what's the state of things today. So just a very quick about myself. So I'm a software engineer and team lead at Rivas. We are a hardware company, but we're also heavily investing in software, given RISC-V ecosystem is pretty still young and growing quickly. I'm also a contributor to the OpenJDK. I was lucky enough to work on the Windows ARM64, Mac OS ARM64, and Linux RISC-V port. There I got to learn about architectures and especially RISC-V. I'm also the language runtime working group lead at RISE. So RISE is a collaborative effort to improve for the development of open source software on RISC-V. So it's purely focused on RISC-V and purely focused on software. As part of the working group, we're looking at OpenJDK, Go, Python, .NET, Android runtime, and V8, the JavaScript engine. But you also focus on the compiler runtimes and ecosystem, meaning the OpenJDK, but also any libraries that is written in Java and that basically needs porting to RISC-V, as we're going to see later. We're also part of the Adaptium working group, where we got to work on the distributing the LTS versions, which I'm going to come back to after. So a quick primer on what is RISC-V. So it's an open source ISA, as in anyone is free to contribute to the standard. Anyone is free to participate to this discussion to define the ISA. It's also royalty free and completely open source, so you can find all the sources and all the discussions on GitHub and on the mailing list. And what's very interesting about that is that really anyone can implement a RISC-V processor. You actually have examples online of people doing in a few hundred lines of RTL code, so of machine description code on RISC-V compliant processor. It's fairly easy to understand, even if you're not familiar with this code, but it shows how fairly straightforward and easy it is to implement such processor. It's managed by RISC-V International, which is a foundation based in Switzerland. And they are really a very broad ecosystem of companies contributing to that, but also like internationally diverse companies. So there are a lot of companies from China, a lot of companies from Europe, a lot of companies from the US, basically every region in the world. And it's also the concept that's based on extensions. So for example, you have the V extension, which defined vectorized instruction. You have C for compressed instruction, ZBA, ZBB, ZBC, and others for bit manip. And you have many extensions which allow for the hardware to really pick and choose what they want to implement in order to be high performance or low energy or embedded or whatever use case, but also for the software to really optimized for what's available on the machine. The target market is really from embedded to servers. So it's anything that has silicon is a target for RISC-V. Whatever is available on the market today is mostly development boards. Servers are coming soon. Some of the server class hardware companies are Alibaba, Ventana, Rivas, Sci5. There are others which I forgot to mention, but these are some of the main players. We expect that it's going to be started to ship late 2024, mid 2025, and that should give us access to much better, much bigger hardware. Today we have around like 4, maybe 8 cores machines, 8, maybe 16 gigs of RAM. They're fairly small. They're great for development. They're great for some CI, but obviously they are not big and run. They're not competitive with like x86 or even ARM. So, but we're getting there, and we're getting there soon. Also, a lot of companies doing RISC-V also targeting AI workloads. For example, Rivas with an accelerator, Temurin with an inference PCIe card. There are plenty of companies doing AI. I think it's really all the rage nowadays, but that's where things are going. In terms of support for the RISC-V ecosystem, obviously we have support for compilers, runtime, and libraries. There is support in many existing projects, among which GCC, LVM, OpenJDK, Go, and others. The support range from very good to it working. So, for example, GCC and LVM are really, and OpenJDK are really on the forefront in terms of support for RISC-V. Other runtimes are starting to get there, but it's not there yet. It is rapidly evolving. As in, a year and a half ago, OpenGK barely started to have support for, or 2 years ago, OpenGK barely started to have support for RISC-V. Now it's really high quality. So it's going very fast. There is a lot to do. And that's also why it's so important to be on the latest and greatest, because that's where the work happens. And it's always a bit complicated to backport these kind of optimizations. And they support in more and more libraries. That's where most of the bulk of the work is left. For example, OpenBlast is supported, but there is still some optimizations to do. And there's many libraries like math, video, codecs, images, anything you can think about in native probably needs a bit of porting work, at least for the assembly, for the high performance parts. But that needs to be done in order for RISC-V to really be competitive as a whole software ecosystem. If you want to find out more on what is supported, you have this great page from RISC-V International. It is not an exhaustive list, but it gives you an idea of the breadth of what's supported. For example, MySQL, Nginx, OpenBlast, PyTorch, Redis, Docker, Go, FreeBSD, and that's just a few. There are many other projects which are supporting RISC-V, but not listed on this page. But that gives you an idea that RISC-V is already mature enough to be functional. Most of the work needed is on performance. So back to OpenJDK, which versions are currently supporting RISC-V? So it was done as part of JEP 422, which was integrated in Java 19. So any version after Java 19 has support for RISC-V. And the backport was also done for Java 11 and Java 17. Java 17 actually in mainline JDK 17 new dev. So it's available in the mainline 17. 11 is still in a separate repo, in the RISC-V port repo, which is fine because it's kept in sync with the 11 repo, but it's not, and I don't assume that it will ever be in the JDK 11U mainline, but at least it's available to the public. Also, in terms of distribution, Eclipse Temurin has done an amazing job. Thank you very much to everyone involved to actually build, test, and distribute these different versions on RISC-V. So right now, today, we have 17, 21, 22, 23, and TIP. Actually, 23 is TIP, but working and distributed on RISC-V. So that's an amazing fit. Thank you very much for everyone involved. Most of the distribution happened this year. So there was really like a great effort from everyone involved. There is a work in progress for 11. There is still a bunch of tests failing. We have to go and fix whatever needs to be fixed in OpenJDK and in Adoptium. I assume most of the bugs are in the OpenJDK. We just need to go and fix them. In terms of features supported, most of the work is still to be done on, most of the work as of the past year has been done in accelerating the OpenJDK. It's functional, everything is supported. It's just, okay, how can we make some of these pieces faster? For example, for everything sitting in intrinsics, there is support for SHA and MD5, but we need to go and accelerate AES based on hardware features. Memory copy and zeroing, same thing. We want to go and make sure we can use the best instructions for that. Everything math, everything vector API, also same thing. There's a ton of work going into vector API nowadays to make sure both the auto vectorizer and the vector API are able to take full advantage of the vector extension. And we're seeing some significant speed up. So that's great work there. A lot of the work also happens on code drawing. For example, you have a graph of C2 operations, C2 being the compiler, C2 operations. You want to lower that to the right instruction and not use either suboptimal or just the wrong instructions. We want to make use of bit manip. We want to make use of vector instructions. We want to use the right instructions for floating point. This is really a very important work. And there is a ton of investment there happening. And then kind of the last layer, which I don't think we have started to really look into, is any optimization in the OpenJDK we can implement in the C2 compiler that would particularly benefit on RISC-V. For example, there work to be done on memory allocation and zeroing. Java applications are allocating a lot. That's just because of how the language is done. Everything is an object, everything is an allocation. So if we can speed that up, we would see significant accelerations of workloads on RISC-V. So there is some optimization that there is some RISC-V specific things that can be done there. And so we want to go and do them because we want to make sure that we can go as fast as possible. Same thing for auto vectorization. RISC-V has a very extensive vector extension, sorry. And so we want to make sure we can take full advantage of it. And so we would want to go and improve auto vectorization in C2 and the OpenJDK so that we can take full advantage of RISC-V. That would obviously benefit other platforms because by improving auto vectorization, we improve everyone. But the driver here will really be what can we do better on RISC-V. And then, more generally speaking, we want to take advantage of everything the hardware has to offer. But given that RISC-V is developed in the open, we can also go to RISC-V and say, hey, if we had these kind of extensions, that would particularly benefit Java and Java workloads or JVM-based workloads. And this is what's happening, actually. There is work to define an extension that would particularly benefit garbage collection. And we are making sure that there are the right tools and that the use cases of Java are taken into account and are highly optimized. And so this is the kind of positive feedback loop we can see between software and hardware by having everything done in the open. That's really, I think, one of the strengths of RISC-V in that case. So the contributors, the original port was done by Huawei. It was reviewed by Red Hat. So amazing work from them. The port they originally submitted was very good quality already. And then we have seen very regular contributions from Huawei, Alibaba, Rivos, Iscas, Syntacor, and a few other I missed. But this is the graph for dedicated to per organization. And we can see that anything RISC-V, for example, Rivos, Huawei, Iscas are representing a sizable amount of contributions for the whole of JDK22, right? So that's why we can see that it's a very active port, it's a very healthy port, and a contribution for a lot of companies. So that is very positive to see. So that's for the OpenJDK on the ecosystem, which is basically any Java program or any program written in Java or targeting the JVM out there. So counting on Maven Central, there are more than 2 million packages. So that's counting every possible packages and I think every possible versions as well. Most of them are platform agnostic, as in they are just pure Java code or pure JVM bytecode. They don't embed anything native. They don't take any assumption on the platform it's being run on and everything. And that's amazing, right? That just works on RISC-V, given the OpenJDK works on RISC-V, right? But some of these libraries have platform-specific code. For example, Neti, it's a networking library, pretty well known. They have some native code to call into the Linux kernel via syscall, like via libc and everything. And these native libraries are embedded into the jars. And so, for example, you have a Linux x86.so jar dynamic library inside the jar. There is an ARM64 one, but we had to go and contribute the RISC-V one. It's not a ton of work because we just have to go and improve their build system. The build system and CI system and everything. That's pretty straightforward, but it has to be done in order for Neti to be supported. Same thing for RocksDB, same thing for Apache Commons Crypto, same thing for Snappy. So there are a significant amount of libraries. We don't have an exhaustive list. That's also a problem. We don't know all the libraries that are used and have native dependencies. So it's kind of a case by case of if someone runs into a library that doesn't work on RISC-V, someone go and do the contribution, right? It's not a big amount of work every time, but it just needs to be done in order for it to be supported. There is also the problem of transitive dependencies. For example, you want to run Spark on RISC-V, great. Well, Spark has a ton of dependencies, and Spark will not work on RISC-V unless all dependencies are actually working on RISC-V, or all dependencies on the code path that you want to exercise in Spark. And that's, for example, what drove the development in Neti, Apache Commons Crypto, in Snappy. That's because Spark and RocksDB as well. That's because Spark relied on it. And so we went and ported these libraries. And so now Spark should be able to run on RISC-V. So that's kind of the work that journey needs to be done. We need the community's input because people who have contributed to that have some workloads in mind they want to support. But in order to have a more exhaustive list, we need the community's input on what should be done. So some of the contributors who have been doing this work, there is RISE, which I mentioned earlier, which kind of helps centralize and avoid duplication. Mostly that if RISC can do one thing well, it's to avoid duplication of work. And there are multiple companies part of it. And we have the wiki, which is listed here, is accessible openly. And I would encourage you to leave any feedback or email me if you have any question. There is Adoptium, which focus heavily on OpenJDK and some of the core frameworks. So same thing here, being able to run the test suite of the different projects, we can make sure that it actually runs on RISC-V. And then there's obviously RISC-V International with the J extension working group, J standing for Java, but like language runtime, like Go, Python is taken into account. There's the management runtime special interest group, and there it's really to specify RISC-V extensions that would benefit OpenJDK, Go, and other runtimes like that. What's next? Well, we want to continue investing in OpenJDK. There are more optimizations to do and more features to support. We want to continue porting ecosystem libraries to RISC-V. Same thing, we need to, I think the main thing we can do is identify and prioritize. We don't know what everything needs to be ported. And it's just like, we cannot know by ourselves. We need the community input. And we need to figure out, okay, what do we need to do first? What do we need to do second? And et cetera. So that's a call to action to everyone in the call and everyone watching this video. Please help us figure out when is porting to RISC-V, what are the workloads that you care for, and we can go and do the work of identifying exactly which packages needs to be ported and do the contribution. That's fine. If you want to contribute, that would be great. But even just helping us identify what needs to be done would be great. And then the second thing we can do is document, support, and sponsor. So we want to make it easier for everyone to be able to port to RISC-V. It is not something, we cannot port the whole software ecosystem to RISC-V. It's just not possible for us to do it. We need everyone's involvement in that. So what we can do is to help make it easier for everyone to look into it by sharing knowledge, by documenting how to test, how to measure performance and all of that. But you can also support and sponsor, sponsoring by providing machines, like CI machines, or sponsoring by providing contributions. RISE also has the concept of RFP, so request for project, which is basically if we identify something we want to get done, we are going to make a call for contractors. Contractors don't have to be a contracting company, right? Anyone who wants to contribute can do it. And then we will basically pay you to do the open source contribution. RISE does not care about closed source software. That's not our goal. We only care about open source software, meaning that any contributions you would do as part of RISE would be paid for, like as part of contractor work, and would be done to the upstream project. So that would be a double gain. So if there is any particular project you would like to get done, please reach out. My contact is on the last slide of the deck, and we can explore together what it would mean to port that. Thank you very much. Do you have any questions?